Hello and welcome to the logic of it all. This is our first video on propositional logic, also known as propositional calculus. In this video, we are going to look at the motivation behind studying logic in computer science and also some basic definitions. The first place that logic is used in computer science and the most obvious example is with Boolean values in programming. Logic underpins conditional statements, loops, and in general control flow in programming through Boolean values. In computer architecture, digital circuits are built from logical gates such as AND and OR gates, with propositional logic forming the foundation of CPUs, memory, and arithmetic operations. In formal verification, logic provides rigorous methods to prove that hardware and software systems behave as intended, increasing reliability and safety of these systems. In programming languages, the semantics and type systems of programming languages are grounded in logic, ensuring programs can be reasoned about formally. In functional programming, in programming languages such as Haskell and F#, the programming language is directly based on logical principles such as lambda calculus and Curry-Howard correspondence. In AI and automated theorem proving, logic enables knowledge representation, reasoning, and automated proof search, powering areas such as SAT solvers, which are essential for many AI systems. And finally, in theory of computing and complexity theory, logic is central in defining what problems can or cannot be solved with machines, and in complexity theory, classifying the problems based on their inherent difficulty. Now, we first need to define what a proposition is. A proposition is a declarative sentence that is either true or false. And here the important thing is that it should be either true or false. It cannot be both. To give you a clear idea of what we mean by this, let's take a look at these four sentences. So I want you to pause the video here and use the definition to figure out which ones of these sentences is a proposition and which ones are not. So if you think about it, the first two sentences are propositions. And the reason is they're declarative sentences and they're either true or false. However, the third and the fourth sentences are not propositions because you cannot think of them as either true or false. So for example, the third sentence is a question, so it doesn't mean to say whether it's true or false. And because of that, it's not a proposition. Now, a common mistake here is thinking that because 2 plus 3 equals 7 is false, then it's not a proposition. That is not the case. A proposition can be either true or false. So 2 plus 3 equals 7, even though it is false, it's a proposition, but it's a false one. Now, this truthfulness or falsity of propositions is used a lot when we are studying them. And the technical term for it is the truth value of the proposition, which is either true or false. And we use T for true and F for false usually. Now, to be able to investigate propositions, we will divide them into two categories, namely simple and compound propositions. A simple proposition, as the name suggests, is a proposition that doesn't contain any other simpler propositions in it. So here are two examples of simple propositions. The first one, 2 is less than 7. First of all, it is a proposition because it's either true or false. In this case, it's true. And it's a simple proposition because it doesn't contain any other proposition that is simpler than itself. The second example, 18 is an odd number. Also a proposition, this time is false. But again, it's a simple one because it cannot be decomposed or it cannot be broken down into simpler propositions. On the other hand, if a proposition contains at least one, so one or more propositions, then it's called a compound proposition. Now here's an example. If 2 plus 2 equals 4, then 9 is an even number. This is a compound proposition because it contains two simpler propositions. The first one is 2 plus 2 equals 4. That's a proposition. The second one, 9 is an even number. That is also a proposition. So because of that, the whole sentence, if 2 plus 2 equals 4, then 9 is an even number, is a compound proposition. Here's another example. 22 is not a multiple of 3. Obviously, it is a proposition, and it's a true proposition as well. But the question here is not whether it's true or false. The question is whether it's compound or simple. Now, this is a tricky one, and it becomes clearer when in later videos when we talk about connectives in more detail and more rigorously we define them. But the way to think about this proposition is, this proposition, what it means is, it is not the case that 22 is a multiple of 3. Now, if you think of it this way, then you can see that it contains a proposition that is simpler, namely the sentence that says 22 is a multiple of 3. So because of that, the sentence 22 is not a multiple of 3 is also considered a compound proposition because it contains one proposition that is simpler than itself. Now, as I said, in later videos, we are going to define these compound propositions in more detail and more rigorously. And the way that we do that is by using these logical connectives. And we are going to look at different connectives such as and or conjunction, or, which is also called disjunction, negation or not, implication, which is also known as if-then, and also if and only if. We are going to look at these logical connectives, how we can build compound propositions using these, and we also look at the truth values of these propositions that are created with these connectives.